Introduction to probability. To learn probability, first we must be familiar with basic terms in probability. Second, we must be able to list out the outcomes of a sample space. And third, we must be able to determine number of outcomes in the sample space. Let's first look at some basic terms in probability. The first term is experiment. Experiment is any process or observation that generates data or results. For example, if we toss a die, we will get 1 or 2 or 3 or 4 or 5 or 6. So tossing a die is an experiment. The second term is outcomes. Outcomes are the results obtained from an experiment. For the experiment of tossing a die, 1, 2, 3, 4, 5, and 6 are the outcomes. The next term is sample space. Sample space is a set of possible outcomes of an experiment. Put all outcomes from the experiment of tossing a die into a set like this, we'll get a sample space. Note that sample space is represented by the symbol S. The last term is event. Event is a subset of a sample space. For the experiment of tossing a die, we could define an event A to be the event of getting even numbers. So the outcomes of A would be 2, 4, and 6. Now, it is important for us to be able to list out the outcomes in a sample space of an experiment. This is because we might need them in calculating probability. For simple experiments like tossing a die or flipping a coin, the outcomes are easy to be listed out. But for a complicated experiment, listing out the outcomes in a sample space can be quite difficult. For a complicated experiment, one of the ways to list out the outcomes in the sample space is by using tree diagram. Now let's look at an example. Suppose that a die is tossed and after that a coin is flipped. Write the sample space. This is quite a complicated experiment because the experiment involves two actions, which is tossing a die and flipping a coin. So to write the sample space for this experiment, we need to draw a tree diagram. Note that each stage of a tree diagram represents each action that we do. The first stage of the tree diagram is for the outcomes of the first action, which is tossing a die. For tossing a die, the outcomes are 1, 2, 3, 4, 5, and 6. So draw 6 branches for 1, 2, 3, 4, 5, and 6. The second stage of the tree diagram is for the outcomes of the second action, which is flipping a coin. For flipping a coin, the outcomes are head and tail. So draw 2 branches from each outcome of the first stage for head and tail. From the tree diagram, we get the sample space. Let's look at another example. Suppose that there are 6 black balls and 4 white balls in a box. 2 balls are taken from the box. Write the sample space. This is also quite a complicated experiment. So to write the sample space for this experiment, we need to draw a tree diagram. Note that for this experiment, each stage of the tree diagram represents each ball that we take. Thus, number of stages of the tree diagram depends on number of balls that we take. If we take 2 balls, then the tree will have 2 stages. If we take 3 balls, then the tree will have 3 stages, and so on. The first stage of the tree diagram is for the first ball that we take. Because there are black and white balls in the box, the first ball that we take could be either black or white. So draw 2 branches for black and white. The second stage of the tree diagram is for the second ball that we take. Again, because there are black and white balls in the box, the second ball that we take could also be either black or white. So draw 2 branches from each outcome of the first stage for black and white. From the tree diagram, we get the sample space. Apart from being able to list out the outcomes in a sample space of an experiment, we must also be able to determine number of outcomes in the sample space. This is again because we might need them in calculating probability. The process of determining number of outcomes is called counting. Again, for simple experiments like tossing a die or flipping a coin, number of outcomes is easy to be determined. Even number of outcomes obtained from a tree diagram is easy to be determined. But for a more complicated experiment, determining number of outcomes in a sample space can be difficult. Now, the easiest way to determine number of outcomes is by using counting rules. There are two important counting rules, namely multiplication rule and addition rule. Multiplication rule says that if action A has m outcomes and action B has n outcomes, and if A and B must be performed together, then number of outcomes altogether is m times n. Addition rule says that if action A has m outcomes and action B has n outcomes, and if A and B cannot be performed together, that is, we only do either A or B, then number of outcomes altogether is m plus n. Let's look at an example. Suppose that a die is tossed and after that a coin is flipped. Determine number of outcomes in the sample space. For tossing a die, there are 6 outcomes, and for flipping a coin, there are 2 outcomes. We want to perform these 2 actions together. So number of outcomes is 6 times 2, which is equals to 12. Let's look at another example. A girl has 4 tops, 3 bottoms, and 2 pairs of shoes. Determine number of outfits that she can wear. Of course, we can try matching the clothes one by one to get the outfits. And by doing this, we get 24 outfits. Or we can simply use counting rule. So there are 4 tops, 3 bottoms, and 2 pairs of shoes. The girl needs to combine the 3 items together in order to make an outfit. So number of outfits the girl can wear is 4 times 3 times 2, which is equals to 24. For another example, suppose that there are 2 male lecturers and 3 female lecturers teaching statistics in a semester. Determine number of ways a student can choose a lecturer. So there are 2 male lecturers and 3 female lecturers. A student can only choose 1 lecturer. So number of ways to choose a lecturer is 2 plus 3, which is equals to 5.